Hello, New Ike Games here with another video on remaking the core version of Getaway Shootout in Unity. Check out the previous videos in the series for more explanation on the series and what Getaway Shootout is. But in the last video, we implemented a health system, and basically we attached this on our player prefab, which is this one right here. And basically it's just a simple health system for right now to keep track of player health, but we can also add it to other objects that will be in the map. But now what we want to do is actually to have something that interacts with the health system. And we had a simple test area that subtracted the health, but I want to actually use what Getaway Shootout does and have weapons and power-ups in the game. And for this video, we'll be focusing just on one particular weapon, and that is the gun. And we'll do possibly other videos on other weapons in the game, but I think gun is the core component in Getaway Shootout. And there's multiple guns in the game, but they all use the same gun script. And that's what we'll be doing today, is actually creating the gun script for the gun, so we can have the gun shoot, and then basically it takes off damage, and also moves rigid bodies around. So we'll be creating that core gun class. And it should be pretty generalized, so if you want to take it and use it in a different game, it should be pretty easy to tune into different environments. So I think the first thing that I'll do is actually kind of just go an overview of what I want to achieve with this gun script today. So I guess first things first, I should note you can create a simple gun script in Unity, as I'll show, pretty quick and pretty simple. So say if you have your gun here, Unity has the raycast system, so if you just do a raycast, and basically that will return to you any collision that happens with that ray, and from that information you can use that collision or whatever collider it hit with to do information like subtract the health, and also to move the rigid body in a direction, add force. So that's pretty simple. That's just using the raycast. And what I would like to do today is actually extend that and come with a generalized gun script. And the two main components that I want to achieve with this generalized gun is collateral damage. And also, I don't know if I spelled that right, but we'll just go with it. And the other thing I want to have is fall off damage. So what do I mean by those two? So with collateral, I want it, say if we have the case where we have a gun again, and this is shooting, and if we have multiple players or even just multiple objects in the way, this will shoot through all of the objects, and maybe it only gets to the third object before stopping out. So when I mean collateral is to shoot through many objects just with one bullet. And I guess the key things to think about when creating a system like this is, one, how transparent are all these objects? So we'll set up kind of just a little value for each object to say how transparent it is. And with these transparency values, this will actually decrease the bullet power. And also the bullet itself, how sharp is the bullet? If the bullet's really sharp, it should be able to go through a lot of objects. But if it's dull, or like something like a pistol, it shouldn't go through a lot of objects. So those are the two values that we'll focus on, is like the object's transparency and then the object's sharpness, and I'll show how we can actually implement that in Unity itself, but it'll be simply just multiplying these two values to get an overall of how much gets transmitted through that object. And then, as I was saying, the other thing that we will be doing is fall-off damage with our gun script. And fall-off damage, all I'm talking about is if you have the gun, basically close objects will be affected a lot more. There'll be a lot more damage applied compared to objects far away. Should be able to receive much less damage. And the fall-off damage that we'll be implementing is just a linear fall-off damage, meaning that the fall-off damage is just correlated to a linear function where it just decreases based on the distance. If you had distance as your x-axis and your power on your y, and basically it just decreases in a constant line. So those are the two main components that we'll be extending with our gun script today. And in the actual Getaway Shootout game, not all the weapons actually utilize this, but we'll actually just have variables that you can set that if you want to disable that feature, you can just change the variables in the Unity editor. So let's hop back to the Unity game engine, and let's start with actually implementing this gun script I'm talking about. So I'm going to hop to our scripts folder, and I'm actually going to create a new folder and call it power-ups, because this is what I name all the sort of items in the Getaway Shootout game that you can use. So I'm going to have it the same like that, and then I'm just going to create our script for the actual gun script and just call it gun. And then I'm going to open this up, and then we'll get started with actually implementing this gun script. So I'll kind of progressively walk through steps of first starting with a simple gun that you can implement in any game, and then going to that more generalized gun that I was saying later. So the first thing we'll start with is just a simple shoot function, and we'll call it shoot. And with the shoot function, we'll do exactly what I was saying in the first, is just doing a simple physics 2D.raycast. And with a raycast in Unity, all you give it is a specific spot where it's shooting from, and then the direction. So like in a mathematics class, a ray in a geometry sense. So we'll do the same. We'll give it an origin, and we could do just the position of this gun, but I kind of want to have like a barrel or like a spot where the actual bullet fires from. So I'm just going to go up to here and actually create a public variable called the shoot spot. And this will just be a transform of where that shoot spot is actually located. And we'll use that position here. And then the other thing that the ray wants is a direction, and we'll actually use the shoot spot as well for the direction. So if I do shoot spot, and then we'll use the transform's direction. We'll use the up direction of the transform, and this will be shooting just with the transform's up direction. So that looks good. This raycast also actually has other parameters that you can pass in. And I'll actually utilize that right away, is just to create other variables. And the first one would be a range. And this is the range of our gun, or I guess better put it, maybe max range. And yeah, this is how far our bullets can reach. So we'll put in a range. And then the last thing that we'll add to this function here is a layer mask. So I'll utilize that as well with defining one up here. So I'm going to say layer mask, and I'm going to call this the ignore mask. And I'll call it that because this way we'll easily be able just to specify the layers that we want to ignore instead of the opposite. And so I'm going to put this back, put this variable into the function. And the way that I'm going to say the opposite is using this, I think it's like tilde or squiggly line, to get the opposite of this layer mask. And basically this raycast will ignore all the masks that we pass in through there. Okay, so that looks good. This raycast function returns a raycast hit 2D, which is basically all the information of what we collide with, and we want to know what that is. So I'm just going to store that in a variable, raycast hit 2D, and name it hit. And basically with hit, we need to check if it's null. So if hit a collider does not equal null, I might need to check maybe it's just hit not equal null. I forget, but we'll see. And with this raycast now, we want to get information about what we hit and apply damage, apply whatever you want. So in our system right now, the two things that we really want to interact with is the health system. So the first thing to check is if this collider that we're hitting has the component health. This was the script that we created in the last video. And I'll just store this as a variable called health. And we just want to check if we have that component. So if this is not null from the get component, then we actually want to do damage on this player on this health component. And this wants a damage amount as we set up before. So I'm actually going to jump up here and create a variable for the amount of damage we want to do with this gun. So I'll call it health damage, and we'll give it a default value of maybe 50. And then also I'll just give this a default value as well, and this will give a default value of 25. These are just variables that just will be helpful for default guns. And we'll just pass in the damage that we do, or in the damage that we specified, which was just health damage. Now that's great. So anything that we shoot and collide with that has a health component is taking damage. The other thing I want to do is to actually make it interact with the physics. So if our component that we're collide with has a physics object, or a physics component, which is just rigid body, do physics stuff. So we'll say this, just copying this from up here, and we just want to check if the rigid body, if the collider has a rigid body, and then just check again if it's not null. And so this means that we're colliding with a rigid body. And I say colliding, but this is just a raycast. So if we're, I don't know, shooting is maybe a better word. And the thing that I want to do is apply a force. So Unity has this function called add force. But what would be even better is to actually do it at position, because with a gun, there's a specific point that we're hitting on the object. So I'm going to use that function. And basically, this function has the parameters listed below. We just need to give it a force. And with the force, I'll actually create another variable up here and call it rigid body force. I'll default it to 5. And I named this a float, so this is just going to be like the magnitude of the force. So we can do that. So rigid body force. But we'll actually still need to times it by direction to be a vector. And the direction, as we specified before, is just this shoot spot. And it's going to be the up direction, since It doesn't change between these two, so it should be the same direction. And we'll just times to get like the overall vector scaled by that rigid body force. So that's going to be the force. And then now we need to know the position that we're applying this force at. And this is where Unity has the helpful information on this raycast hit 2D. There's a point variable, and that's basically where the point we hit the object. Okay, so we could add more interactions here. Basically, if you have other scripts that you want the gun interacting with, you could add all these checks below. But for our scene, it's pretty simple. These are the only components we really want to interact with, so I think that's good for now. And I'm going to actually go jump back into the scene to test this. But actually, before I do that, I'm going to set up just a simple test input system to actually shoot this gun right now. And the way I'm going to do that is like in a previous video, I'm just going to get the current keyboard, and if the spacebar was pressed, then we just want to shoot this gun. And this is just a temporary key binding for right now. We'll actually get players to shoot in the future, but it's going to be a lot easier to test this way. Okay, so that looks good. Now let's jump back to the scene and actually create a gun in our scene to fire. So before this video, I actually imported a sprite. This is the original sniper sprite from Getaway Shootout, and this is what I'll be using just for our gun sprite for right now. So I'm going to drag it onto this box here and kind of have it set up as like a static gun for right now, since it's not going to be on a player. And the one thing that we set in our code was to have a shoot spot. So I'm going to create a transform to specify that location on our gun. And I'm just going to drag that to wherever we want it to be shooting from. And I'd like it shooting from the barrel of the gun, so that's what I'm going to do. And the only thing left to do is actually add the gun component to this gun. And this is where we have all the variables that we set. I'm going to drag in that shoot spot transform to set that transform. The ignore mask, in our case, we actually want to ignore some layers, since when we're setting up the player, we have this arm layer that basically is just there for the physics system, and we actually don't want to collide with these arm colliders. So I'm going to set to ignore the arm layer. You can click to select other layers as well, but yeah, arm's just good for right now. Health damage I'll leave at 50 just for testing, and yeah, all these other variables look good. I'm just going to give the gun different direction by changing the scale. And also one thing that I'm forgetting about is actually to set the direction of the kind of the shoot spot, the barrel almost. And I'm just going to rotate this by giving it a rotation on the Z right here. And basically we defined the green arrow, the up direction, to be the direction bullets get fired at. So for this case, that looks good. That the direction is going to be out of the barrel. And I guess the next thing to do is to actually test this. So I'm going to hit play and actually test this with our players. So we won't see any shooting lines or anything like that, because we did not set up anything in our scripts to have lines shooting yet. But we'll still see like the actual underlying physics applied to it. So let's see if that works. So I'm pressing spacebar. Doesn't seem to be doing anything. Oh, okay. So it did seem to kill the player. Okay. So I think I know what's happening. So it is working, but the reason why it looks weird and doesn't look like it's doing anything right now is because this rigid body force, I gave it a value of 5, but I was intending to actually use a different force mode for this. So if I set force mode to impulse, this should give a lot bigger force applied to this object. And basically, like, impulse is just used, I guess I don't know the exact difference, but I'm pretty sure it's just used more for like one frame calculations for adding force. And that's kind of what we want to do, since it's just like a one frame gun shooting. The other one is just the force mode, and that's what we're using before. But this should give us a lot bigger damage. But you can definitely use either one. But I think in our scenario, it's just more better to use the impulse. So now I'm going to do the same thing where I click spacebar just for the testing purposes. Okay, so obviously now it's looking like player actually gets shot. Again, there's no line. We'll get to that later. But the player actually gets shot. And I'm going to shoot twice, and the player should die. Looks like it's still alive because we set the... Okay, so its current health is at 0. So this is actually good to find because this is an error with our previous logic in the health system. So maybe I'll just fix that right now. A health of 0, we want to actually kill the player. It should be 0 and below. We should kill the player. So I'm going to go to our health system and find the code. So yeah, this is exactly what I expected. So we're only dying if it's less than 0, but I think if you are equal to 0 as well, you should die. So that's just a small change. But yeah, it makes more sense in our gun scenario. So if we just jump back to testing, it should be 2 shots to kill the player, and the first player dies. So that's a simple gun system to get started in your games, whatever you're making. And it works fine. There's no issues with it. The one thing that I would maybe make a change is to actually have the gun ignore the player itself, and we'll actually get to that at the very end of the video. Yeah, that'd be kind of the only change I'd make, but this would be a working script just for simple guns. Now this is when I actually want to talk about what I was talking about earlier with the 2 main things that I want to add to this gun script to make it more general. And the first one being is the collateral damage that I was talking about. So you have 2 players here. I want the gun to actually shoot through the first player and hit the second player as well. This is known as collateral damage. So yeah, that's what I want to get implemented in. And then after that, we'll do the fall off damage, where if you're further away, you'll take less damage from the gun. So yeah, those are the 2 things that I want to add to this gun script to make it more general. So let's hop back to the script. And we don't need the health script anymore, but so yeah, let's start with the first objective, and that's collateral damage. So the way to do that, we can't really do it with the current system, how we have it. And that's because we're only shooting 1 raycast and stopping right away when we hit an object. What we actually want to do instead is something very similar, and Unity provides a method for it, is doing raycast all. That means it shoots a ray through all the objects, doesn't stop when it hits the first one, and basically goes through all the way. and that will be used obviously in our collateral damage. The only now change that we have to do now is to make this an array, since this will give this all the hit components that we hit. And so yeah, okay, now we're raycasting all, and now we, instead of just checking the first component, we want to actually loop through all these components that we hit. So I'm going to do, well, I'm first actually going to just rename this as raycast, like RCS, for all the raycasts. And then I'm just going to loop through this variable, raycast hit 2D. I'm going to loop through each one as hit before in this RCS. So we're looping through all of our raycasts, and we basically want to do the same logic as before, which is basically this right here. I'm actually just going to quick refactor this to have this into a different function. So I'm going to move this over up to here. So I'm going to have a function called hit object. And this is just going to pass in the hits as before, the same hit collider. And we just want to do the same interactions as before. And we'll just basically pass this hit object in for every collider that we hit in this raycast, which we'll do this. So let me just explain that a little better. So we're raycasting through all the colliders, and with this for loop, we're basically looping through each collider that we hit in this long raycast. And with each collider, we want to do the same thing of just applying damage to the health. So we can actually, with that small change, just go to the code and test if that actually changed it, actually made it so we can hit multiple players. So if you do it now, now both players got hit, as you can see there, which is exactly what we want with this sort of collateral damage effect. But just to give an example of one kind of error that's happening right now, something that's unexpected that we don't want. If I add a little box here, and let's say like this is like a solid box made out of metal. We don't want to shoot through this, but with our current system, if I press space, it still shoots through that solid box. And we'd want the bullet actually to stop at the solid box and not hit the players. So it's not doing exactly what we want. So let's fix that. And the way to do that is, well, I guess multiple ways. The way that I'm thinking about this, and I actually didn't implement this in the original Getaway Shootout game, but I think it's going to be a nice system, is to actually create a new script and call it like object properties. So that's what I'm going to do right now. And I'll make it like a map object for anything that's related to being in the map, like players and objects. And as I was saying before, I'm going to call it object properties. And the idea with this is I assign to as many objects as I want, and this will just specify that transparency attribute that I was talking about before. So I'm going to say public float transparency. I don't know if I spelled that right, but hopefully I did. And yeah, as I was saying before when I was drawing this up, is that the idea is to have each object be a value on this transparency scale. 0 being not transparent means that the bullet stops at this object, can't go through, and 1 being fully transparent, where the bullet can go all the way through with no impact at all. So the next thing to do is actually to utilize this object properties script. And the idea too, maybe in the future we're going to add more properties to each object, maybe like particles for that object and so forth. So I think it's just going to be good to have some sort of object properties script. And so jumping back to here, one thing that we want to do is actually access the object property. So if we do hit collider get component object properties, and then we just basically again want to check if it's not null. Oops, object properties. So if it's not null, well, we want to get this value of transparency. But what do we want to do with it? Since can't really do much here. Well, so I'm going to refactor this a little bit. I'm going to say this returns a float, and this is going to be the object's transparency. And I'm just going to say return, obviously, then the transparency. But if it was null, just return 0. So every object just by default defaults to a 0 transparency, meaning you can't shoot through it. And the only thing that we have to change through here now is to utilize this transparency. So I'll start simple. I'll just say if the hit object has a transparency 0, break. Stop looping through your objects. Stop the bullet. Don't continue further. So I'm gonna bring back that box. Let me see. It was in sprites. So I'm gonna bring this box back into the game because it's gonna be helpful to test. And I'll add that object properties, and I'll add box collider as well. So by default, as a default transparency of 0, we'll use that for testing just right now. The other thing I'll add is jumping to our players prefab. I'm actually going to add this object, this transparent or this object properties. I'm going to do it on the ragdoll object since the player is a prefab variant off of it. So I'm going to say object properties, and I'm going to give players maybe a default value of half a transparency, and I'll get to exactly what these like fractions will actually mean in code, but I'll just set that for right now. And now let's go back and test to see like if this scenario of shooting through a solid box stops. So I'm going to press spacebar. Okay, so again, we don't have gun lines yet. Like we can't actually see where the bullet's going, but like I'm pressing spacebar and the players are not being shot at. Now if I, let's see, if I change the transparency, if I increase it, the players will get shot. But say if there's like just a small transparency, I don't want the players to be shot at full force like that just happened. I want it to be like the bullet really slowed down and the power really decreased. So I think that's going to be the next thing to add, is to kind of slow the bullet down or decrease the bullet's power each time it goes through something based on the transparency. So to do that, I'm going to actually add a new variable just in this shoot function and call it the power. And this is going to be responsible for the bullet's power throughout this whole shooting action. So it starts with a value of 1, or you can think of it as 100%. And instead of doing this here, what I would like to do instead is to, what I'd like to do instead is actually to multiply the power by each transparency. So if it's a transparency of half, this decreases our power by half. If it's a transparency of 0, it'll do it as before. It'll decrease the power to 0. The only thing now is we have to actually pass in this power. So I'm going to say float power and pass it in. So the only thing now is we have to actually implement this power into our interactions here. So I'm going to say when we're damaging health, just take the max health damage here and times it by the power that we pass in. And also do the same with the rigid body. So the max force here just times by the bullet's power. And this is obviously, again, a value between 0 and 1. So it's always going to be equal or just decreasing it. So that looks good. Now we can actually go right back into the game. I'm going to say, I'm going to set this as a transparency of 1/4. And we can go right into testing to make sure that this is working. So I'm just going to move the players back a little. The first player, well, let's follow the gun bullets path. Bullets going to pass through this. It's going to lose a lot of power through this. And then it's going to hit the first player. It should cause damage on the first player, travel through the next one, and go to the second player. And I just press spacebar, and that's exactly what happens. And you can see that definitely is not the full force. And the second player is definitely getting the least amount of power or, I don't know, bullet spray into them. So, yeah, that looks good. So, next, the next thing to do would be the fall off damage. So it looks like we've got the collateral damage implemented in the code, and that looks great. Yeah, so the next thing would be to actually do the fall off damage. And what I'm going to do for that is a pretty simple change. All I'm going to do is to subtract the power. Basically, every time we travel some distance, I just want to subtract kind of a fall off power scale. And I think this is actually a good opportunity to explain this more by visualizing it. So I'm going to go to here. Okay. So I'm going to, draw this to make more sense of what I actually want in the code. So what I'm thinking about is doing, again, what I mentioned before, is some linear function that decreases based on the distance. So if we have distance and we have power on the y-axis, obviously you start with your power at full 100%. And the more distance you go, you just decrease by a linear amount until one, you can stop. This would be obviously the max, or we called it range in our code. So this would mean the fall off goes to 0 at the maximum range. But in our code, we'll actually create a variable to specify what the power is at the maximum range. So you could have it 0. You could have it at 1, and that would mean there's no fall off damage. It maintains a flat line all throughout the distance. Or you could have some value in between like that. And I'll actually go ahead and I'll be naming this the fall off. So that's the definition of what this variable is going to be. And it'll actually be so inverted. So a value of 1 means it falls off completely. So complete fall off. And then a value of 0 is no fall off. And then everything in between is what I was mentioning in before is how much it falls off at the maximum distance. Okay, so that was kind of just an explanation of like what I'm going to be doing with this code, because it can get a little confusing now that I'm implementing it. There'll be some math involved, but at the end of the day, it's not too hard, or it's a pretty simple function. So I'm going to create that variable now that was called fall off that we were just talking about. And I'll give it a default value of 1. So that means at the maximum range, it's going to fall off. It's going to have 0 power, basically. The bolt's going to have 0 power, and smoothly just interpolate between that. So now we just got to implement this into our code. Basically, we want to decrease this power by that fall off, but we don't know how much distance we're traveling. Just this is basically looping through each collider, but these colliders could be very far separated. So we need to actually calculate the distance between these colliders. And the way I'm going to do that is call, just to keep track, a previous distance. And I'm going to set that to 0 at the origin right away. And at each iteration, I'm going to say previous distance equals this distance. So this raycast 2D has this property called distance. So I'm just going to set it to be the distance. And the way now that we can calculate the distance that we traveled in this loop, this iteration of the for each loop, is just the simple, the hit distance again, minus the previous distance. So that's the distance that we traveled with this bullet so far in this little loop. We now want to calculate the fall off. And just doing some math, we can calculate the fall off by, basically timesing it by that ratio of the fall off to the range. So if I do something like fall off divided by range, this should give us the difference in fall off, or difference in power. And we can actually just put that right to the power. So basically we're decreasing the power by this fall off amount. So let me actually just quickly explain, because this is maybe a little confusing, why it's this formula here. This is the distance that we traveled. This is the maximum range. So when we've traveled a maximum, let's say the range, this will be range divided by range, that equals 1. And basically we want to then decrease the power by the fall off value. So if the fall off is 1, then we decrease the power, then the power would be like 0. Then it'd be done. And I guess you can go through the other cases in your head, but that should be reasonable for our gun. Just a simple sort of linear fall off. And yeah, let's just test now that in our code. Okay, so I'm just gonna move this square kind of up out of the way for right now, and I'm gonna check on the gun. So our gun has a range of 25. I don't know, that'd be something over here, and we have a fall off of 1. And as I was saying before, a fall off of 1 means when it's at the maximum distance, there'll be no power, and it would be linear everywhere in between, from max power to 0 power. So I'm going to test this now and bring the players basically all the way over here just to test if they're, just to test if it's definitely decreasing. So I'm going to press spacebar. Okay, so that looks like it did decrease the health a lot less. I'm going to go to the debug mode to actually see what this player's health is. Okay, so it definitely didn't decrease by 50 there. Decreased just about 25. And the second player also actually decreased due to the collateral damage, but it was even less due to that collateral effect, and that's farther. So if I move this player forward, this player should get full damage, which is about 50 pretty much, and this one should get a small amount again. And that's exactly what's happening. Okay, well, that's good that I'm actually checking these values, because this player is actually getting healed by the gun, which we don't want, so we obviously did something wrong. And yes, okay, so what we're doing wrong here is the following. Basically, with decreasing this power is what we want, but we could get into cases where the power is less than 0. And if it's a case like that, we want to actually stop shooting the gun. The bullet just stops wherever it is. So let's just put that like that. And I guess this gives me an opportunity to add another variable. And I'm going to go up here and call it stopping power. Basically, this is just the value of, and I'll set it less than equal. This is just the value that if the power is lessened, the bullet just stops. It doesn't continue forward. So yeah, that looks good. And that bug should now be not in the system anymore. We could do a quick check just to make sure that it's not. So if I go over here, players far away. Don't think that player got really shot there. Let's check. Oop, select the wrong player. Okay, maybe let's move this guy a little closer. Okay, so it does definitely affect him, but since he's so far away and there's someone in between, it's hardly affecting the player. And this is a case where you might want to include this stopping power component, because if you don't want that like little small damage applied, it'd be nice just to kind of ignore those. And so if I jump to the gun here, oops, where's the gun? Okay, gun. I'll switch back to normal mode. If I add a little stopping power, so say the bullet needs to be at least 15% of the top power, now this player should never get hit, never lose health. Let's see. So if I press, oh no, this is the wrong player. If I press spacebar, okay, good. So you can see right here with this value, the health is not decreasing. Only now I just shot him because the first player was dodging it, but yeah, that seems like it's working. So those were the two main kind of components I wanted implemented into this gun script. The one kind of last variable I'll add is actually another float, and I'll call this the sharpness. And this was, again, what I was talking about at the beginning of the video, how sharp the bullet is. We'll give it a value of, I don't know, 0.5 to start with. And all I'm going to do to implement the sharpnesses is just basically multiply the sharpness by, and remember, hit object returns the transparency. So multiply sharpness by transparency, and that's how much to decrease the power. In this case, we're just multiplying the power. So this value would be some value between 0 and 1, usually less than 1, and this will just exponentially decay the power. So that looks good. Yeah, I think that will work fine. We can go back, just to give a quick example. If we set the sniper to have a value of a sharpness of, like that, sharpness of 0. This should be like the no collateral gun. So as you can see, the second player is not getting hit. So this is a nice way to be able to have a general gun script, but then have options to disable collateral like that. And then if you also want to disable the fall off, again, you can just set the fall off to be 0. So it should not decrease in range. Okay, so yeah, all that's looking good. It's pretty simple script. The last thing to do, and probably it's gonna be the most kind of difficult part, is to actually visualize this shooting with like a bullet. In Getaway Shootout, it's just lines. So visualize, the shots with lines. And since that we're doing it kind of with this collateral system and basically multiple stages of moving through colliders, it's going to be a little more difficult. You could just implement basically at the end of looping through everything, just to do one line that goes from the shooting spot to the end spot, and the end spot would just be like the last spot it hit. You could do that, and that's actually what I do in the Getaway Shootout game. But I think this gives a good opportunity to make it more generalized, to actually show the information of the decrease in power at each step. So it'll show basically the power all throughout the bullets line, but it's going to be a little more difficult. But I think I'll just get started with that. Okay, so let's jump into it then. The first change I'm going to make is actually to have this shoot function return some data about all the colliders that we pass through. You could just return this, but I'm going to calculate it to be nice and just one class that it returns. So I'm going to name it maybe shot data, and it's going to be an array. Again, it was all the little lines that connect our shot together. Basically, that is from each kind of for loop, or each loop in the for each loop. So that's what it'll be. Okay, so now we need to create this shot data. And as I was saying, the goal of this shot data class, I'm going to make it public, is just to contain the information for each line connecting the shots together. And the reason why it's segmented is because, again, each raycast gets split up by the collider it passes through. So it's going to be the kind of string of lines between all the colliders. And I'm just going to go for it and make it, and it'll probably make more sense when I start making it. And I'm going to make public float and just call it the distance of this line data that we're dealing with. And then the only other two things that I'm going to include for this visualization of the line is going to be the kind of the float, the power. It's going to be a float of the start power of the line. So basically, how much power is at the beginning of the line, and also how much power is at the end of the line. The idea is to actually just use this for visualization, and the line will be have a higher opacity if it's a high power, and more translucent if it's low power. And this is now I'll reiterate that this solution that I'm creating right now is very specific to this gun scenario. Again, you can just simply just create one big line if you don't really care about this collateral, and to visualize it based off the power. But I think it'll look cool if we do it this way. So that's why I'm doing it. So we have this now class. The next thing to do is just to actually construct this array and return it from the shoot function. And the way I'm going to do that is using just actually a list here. It's not as optimized, but it's just going to make it a lot easier in our case. We can always optimize in the future. Make it a list of shot data and call it data, and give it to be a new shot data list. And then I'm just going to give the default capacity to like 1 greater than the length, since it's always going to be maximum of that. And we'll have to actually implement or use that collections.generic, to use the list. And now with the list, all we want to do is add this data. Basically, it's just the data from the raycast, but just encapsulated better and just in a better form for our graphics to be used when creating the line. So I'm going to create it right here. Basically, when the line decreases in power due to the fall off, and it's still shooting, like the bullet's still going, it's definitely greater than the fall off or stopping power, I'm going to add in this this data to the shot data list. And to do that with lists, you just do add, and I'm going to give it a new shot data item, and this is going to contain all the information that we specified here. I'm just going to make a quick constructor. This is going to be how you initialize the class, and you can do that easily just with a couple buttons in Visual Studio, or you can type it. So then I'm just going to pass in this data. So the first thing that we want to know is the distance. And that's just going to be the distance of the collider that we're colliding with. And the next thing is to give the start power of this line visualization. And the start power, well, this is definitely going to be the end power. We need to have a way of like storing the start power. But I'm actually going to do the reverse. I'm going to actually store the end power. I'll call it like new power maybe, because we'll use it later. And it's just going to be power, basically just this line right here, duplicated. And we'll get rid of this right there. And now we just got to change things up a little to kind of make sure that we're using that. So this way now we can use the original power, the power that does not have the fall off damage applied to it. And then we can also use the new power, which is the fall off power corresponding to this line. And yeah, that all looks good. The next thing to do is actually, since now we changed this, we got to re-implement this back. So power, well, how we had it is power times like this. We now want to actually use new power, so we just implement new power like that. So nothing's changing, it's just like the way we're storing these variables to make this shot data work. And yeah, so that looks all good. I guess we should get into the case of actually returning the shot data. So at the end of this data, we want to return data that to array just like that, which looks good. But one thing to note, there'll be a slight issue with our code so far. That's because if we get into a case where we're midway through a line, so we're like, I don't know, say if we're firing our bullet, and then our hit position's right here, but basically we lose, we stop power right there, like that's where we power dips below with the fall off damage. We want the line to actually stop right there. We don't want it to continue. Well, actually, right now it's not even displaying this line we want to kind of show a segmented line. And like, yeah, before, if I had like something like this, yeah, I guess this would be a good way to visualize. So these O's are going to be the colliders. So we get into a case where like the line died midway through. Currently, how we have it set up, it will go all the way up to here, and then it won't show a partial line. So what I'm trying to say now is we want to have a way to show this partial line, and we'll actually do it outside this for each loop. We'll just add the remaining sort of distance to this shot data list. So I'm going to do add new shot data, and this will require just a little bit of math to calculate how much more the line has to go after this data, or after this collider here. And I'll just do that quick. So obviously we want the distance to be the previous distance, so that's this collider here. And then we're gonna add some distance now. We just want this line segment, which we can calculate with a bit of math. Maybe I won't explain this as much. Basically, we take the power, which is calculated right there, and minus it the stopping power. So basically, we're getting the amount of power that we never used, and that's how far the bullet should end off. And the way to calculate that is to times it by basically the inverse of this. So that's going to be range divided by fall off. So that's how you calculate distance. Maybe I'll explain it more at the end of the video. Let's continue for right now. So the other things that we need to give it is the start power, and then we'll also need the end power, which we know the end power is always going to be stopping power. You're never going to break out of it if it's not. So I'm going to give it stopping power. And then, yeah, that looks good. So that's adding that last line segment. It gets a little hairy, I understand, but this way now we'll be able to visualize that better. So I'm just going to go in and add actually another case that I'm just seeing here. So when we set this power here, the power could dip below stopping power again, since we're decreasing it by the sharpness and then the transparency. So it could dip below again, but in this case, that means the line was, say we did this again, it's stopping at a collider, so we don't even have to worry about adding this whole other line again. We can actually just return the array how it is right now, and it should give the correct line. Okay, so again, this is definitely maybe a bit overkill and a bit hairy. So you can definitely get around this by just doing simple lines. I think it'd be cool to see in the editor and in the game kind of this how the power decreases throughout the line. And this sort of class is going to help us kind of visualize it. And that's the next thing that we're going to do, is to actually visualize the line. So I'm going to create a new function. I'm going to say public void use. I'll make it public just because we'll actually use that later. And we're going to call that shoot function again. And basically we get all this shoot data. It's kind of all this shoot, it's getting all messed up. Okay, so we want to do something with this array now. I'm just going to name it data. So this is the data that we want to visualize. At this point, all the objects have been calculated, everything's been hit. This is just purely visualization at this point. And what I'm going to do is actually create a new object to handle this. And I'll go back to Unity to create it. And I'll create it under the power-ups folder. And scripting. And I'll just call it gun line. And basically, it's just going to be responsible for displaying this gun line. So public void create line, and then we're just going to pass in that shot data and give it data like this. So the responsibility of this script is just to visualize this data that we collected with our shot. And I was, before this video, kind of like going through options of how an easy way to visualize this. And the line render is almost there. It's like you can't really set each vertex, or it's like hard to set a gradient for the whole line renderer without making like a bunch of vertexes. So what I'm going to do, just for the simple case, it's not the most efficient. You definitely can find ways better in the future, but I'm just going to create a bunch of line renderers segments for each line. And again, I'll pass in that picture because I kind of like it. Basically, we're going to be creating all these lines between the colliders with the corresponding powers. Basically, there's going to be a start power, end power, and so forth. So I'm going to do that. I'm going to loop through the data. So for each gun shot data, call it maybe just D short, and it's complaining. Okay, maybe there's an issue with like that class isn't able to do this for each loop, but I'm just gonna continue. Maybe just with a for I. Oh no, that's what. Okay, all right. We can go back to the for each loop. Sorry there. So something like this. And now this is where we want to create each line. I'm just going to pop up the script that I created before this video. So I just have some reference here while I'm creating it. And yeah, so what we'll want to do is create a line renderer for each component. And actually, I'm going to make it a prefab so you can choose your own line renderer. Call it line object. And basically we just want to create a bunch of lines, all these lines connecting through the colliders. So instantiate line object, and we'll give it, I guess the line renderers really don't need a position, but I'll just give it I don't know, vector2.0 then, and then quaternion identity. And then, let's see. So we'll get the component, just set it as like that. I'm not going to go explain as much because this is just like graphics side. It's not really that much of functionality in this. So I'll just go through this quickly. I just want to set the positions of this line renderer, and you do that by index. And basically we want the first position to be, well, we'll have to think about this for a little bit. So we should store like our previous position as a vector2. And the first one is actually going to be where the gun barrel, the shoot spot is. So I'm actually going to give that, I'll make it a transform. Again, just that shoot spot that we previously set up. And that's just going to be the shoot spot position. So I'm just referencing this because we'll need it to keep track of the old position. And so it's always going to start from the previous position. And then the next one's going to be the current position. So that's s dot dist. So this is just a float, but since we know there's a direction attached to this, we can actually just do that up again times the distance. But we should also note, let's see. Oh, well, I was going to say we could do pre-position, but we should do just the first position. So that's just the shoot spot again. Something like that. So that looks good. And then the last thing to do with this visualization is just to set the gradient. So basically I just want to have the line transparent if it's weak in power, or really opaque if it's full strength, full power, whatever you call it. And with the line renderer, it's kind of hard to change the gradient in the code, but this is how you do it. So we'll create a new gradient object. And then this gradient object has the alpha keys. This is basically what we want. You don't have to worry about this too much since, it's not that important. And the alpha keys is just an array of the alpha keys. But the important part is just like setting, we just want the first alpha key to be the start power, and then the next one to be the end power. So just gonna do that like this. And you have to give it a position, something like this. Basically, so yeah, this is just saying we're setting at the beginning of the line an opacity of this, and at the end of the line opacity of this, and then this gradient is just going to smoothly lerp between the two. And the last thing we just have to do is to set that to this line renderer, set the color gradient to be grad. And also, I guess one thing I forget is setting that previous position to be, well, I guess we can store it up here. Maybe I'll just say position like that, and do something like that. This way now I can not have to reference it twice. Okay. So yeah, don't worry too much about this. This is just visualization, but yeah, that should be working. I guess, yeah, let's check if this is working now. There'll be some little small tweaks that we can do to this. But okay, so how are we going to do it? We're going to create a component or new game object, call it gun line, and this is where we want to attach this new gun line, and it's wanting a line renderer. This is going to be the individual lines connecting together. So I'm going to pass in the line renderer, and I'm actually just going to create this as well. So I'm going to say line, I don't know, gun line segment. See, yeah, the solution is like not perfect. That's why I'm not going into too much detail. So there could be a lot better solutions to this. But I'm just solving it with the line renderer right now. And I'm just setting the width to be pretty small to begin with. And yeah, that should be good. So I'm going to make these prefabs now. So to make them prefab, you just drag it into the project. I'll just drag it, yeah, this. And then on this gun line, we'll just drag in this other prefab. So we have two prefabs, which isn't ideal, but it's all good right now. I might, yeah, change this up in the future. Okay, so the last thing to do is to create this gun line, and I'll give it another variable. This will be maybe, yeah, we'll call it line, and we just want to create a new gun line every time we shoot this gun, and that's what we're doing down here. So I want to do instantiate line.gameObject, and I'm just going to get the component of that gun line. And then just set that line, forget what I called it, create line, yeah, create line, and then pass in the data. Oh, and then also shoot spot, okay. So now we just need to assign that line to the gun. Let's see. Oh, it's this one. Yeah, gun line. Okay, there. Let's see if this now works. Yeah, a bit of a setup for all this. But yeah, let's see. Okay, so didn't see anything there. Did it create? No. Yeah, I don't see anything created. Okay, so we're not using this use yet. So let me actually use use. So instead of shoot, we're using use. And yeah, that should work fine. Now let's see if that's working. Oh, little pink lines. That's not exactly. It's almost working. So it seems like the start position is wrong. I wonder if it's because. Oh, interesting. So one of these is not being set. Let me hop back. Maybe I might have accidentally not changed that in the code. Let me check. Okay, yep, I didn't. So something like that should work. The pink line, I think it honestly might just be a problem with what we created our line renderer as. So if I jump to this component, the line renderer, do we have a material set? No. So I think that's what it's complaining about. We should just define, maybe just give it to the sprite's default material as default. And let's try that. Okay, so I'm in spacebar. Okay, so that looks good. And because the lines stay permanently right now, you can actually just, it won't be destroyed. You can see it. And you can see, I think it's working at least, that the first one hits, and then you can see the second player gets hit, and then you can see it decay. If we step back, you could maybe see, I'm just going to delete this first one. I'll change one thing, but so if we step back, shoot, so you can see it did hit the player. Well, that's one thing. The player didn't get orientated correct on the rigid body. I'll fix that actually. Maybe I'll do that just at the end of the video. That's a simple fix. But yeah, you can see the line is decreasing with strength, with the fall-off damage, and then there's a little collateral damage. Yeah, everything's looking pretty good. I'm just gonna quick add in that so lines get destroyed after a certain time. So I'm just gonna do public float. I'll call it fade time because ideally I want this to be like faded out. I don't want it to just be quickly destroyed, but for right now it's gonna be fine just to do destroy our game object. And the only other thing that I noticed while we were doing this is we want to set this parent to be us, to the gun line. This way it just won't clutter the scene as much. So I'm going to do something like transform to set it to be this owns parent. And yeah, let's see. As you can see, there's like these restore things. I think it's just a glitch with Visual Studio right now, but yeah, that's not really corresponding to the game. All right, so let's say I click it. Okay, it spawns in, and then yeah, it dies. It looks a little weird because it's so abrupt. This like transition from, if you can see, transition from like strong power to weak power, like that. You can kind of see it there. But I think if you once like you add like particles to the system and other effects, you can. I don't think it'll be that noticeable. This like strong change there. I think it'll be fine. But then yeah, it kind of gives you a nice visualization of what's happening with this collateral power. Like if you're far away, you can kind of see it, like this player doesn't even get hit because it's dying out before then. So yeah, I think it's all working. Yeah, I think that'll be good for right now. But yeah, if you have an idea for a better solution for displaying that line, obviously creating a bunch of line renderers all at once like that is not really good optimization wise. So you could use game pooling and such. But there might be other ways to maybe just use one line renderer or other options as such. But I should note in the original Getaway Shootout game, it's only just one line renderer, which is just like a constant line of thickness. And actually, I should even note there's only one gun in the game, the shotgun, that has fall off damage. So again, you can obviously kind of tweak these settings in the gun to decrease, to take off fall off damage or to take off collateral damage. So yeah, I think it's a nice kind of setup to be able to tweak your gun like that. Yeah, so I think that's going to be it for this video. What is next? Well, what I'm thinking is actually maybe I'll just add the other weapons in the background and not make it a video. So, because yeah, it'll take a little while, but I think the next video we can actually just focus on actually picking up these guns. In the game, there's like power-up boxes that when you hit them, you pick up that gun and you can start using it. Because yeah, right now there's the spacebar thing is just a temporary thing for this video, and yeah, I guess it'd be nice to have that system implemented in. So yeah, that's what we'll focus on next, the power-up pickup, and then yeah, we'll go from there. Thanks for watching, and see you next time.